then Queen Mary's College, and Beverett Hyderabad Engineering College. Totally 50 participants are allowed for this course. Then next I'm going to introduce a person, backbone of the person, our head of the department, Raja Rajeshwari Ma. Without her, this association is impossible. Association is IIT and conducting this course online throughout 20 hours. She'll be with that as a backbone of this program. A special warm welcome and good evening to Raja Rajeshwari Ma. And the hero of the program, not a hero, brother, father of data science program of our department, Dr. Arun Rajkumar, assistant professor, computer science engineering, IITM. I'll give a small introduction about him. He started his career as a research scientist at Xerox Research Center, Bangalore, for 3 years. And his research areas are machine learning, rank aggregation, statistical learning. That's why he is conducting data science for us as an elective course. Since 2019, he has been working as assistant professor in computer science engineering, IITM. He has published 1,451 publications. Among that, 12 articles are Hutch indexed, 13 articles are I10 indexed. He is having both PhD and MS scholars in his specialization area. And the award for best MS thesis in 2011 itself as MNS Swami Gold Medal. And he received Shining Star Award for outstanding scientific contribution at Condon Research Lab in 2017. And he received Young Faculty Recognition during 2022. And most power important introduction about him. He is offering 8 NPTEL course in Tamil. And the topic, Introduction to Machine Learning. For our remote people, I think so, he is conducting the courses in Tamil. Thank you so much, sir, for considering the down south remote students. Thank you so much, sir. Sir, the session is yours. Welcome, sir.
Thank you. Thanks a lot, madam, for the introduction. I'll just try to get my screen sharing working just to see if it works. Okay, great. This. Yeah. I hope you can all hear me and see me well. So I hope I am audible and I am also visible.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you.
Yes,
Thank
sir.
you very much. Thanks, madam. First of all, thanks for organizing this and also inviting me here for the talk. And I'm very happy to be part of this 20-hour data science introduction course. I think last time when we did that, it was only for the Madurai Meenakshi College for Women. And so I kind of took the liberty to do the entire course in Tamil. I think this time we have folks from Hyderabad as well. So, so that everybody is on the same page, I will do this in English this time, right? So I'm assuming that there's a mix of both Tamil speaking and Telugu speaking people in the is that correct?
Yes, sir. Yes, sir.
Okay, sure. So then I'll stick to English this time. Yeah, so just before I proceed, I just wanted to make one small correction to what Kanaka Durga madam mentioned. So I don't have 1,641 publications. I think they are the number of citations of my publications, perhaps, but not the number itself. So I'm not that prolific in terms of publications. Anyway, with that kind of out of the way, so welcome again to this online session on data science. So my goal here today would be to give a very broad overview, rather introduction to data science, and specifically to machine learning. Why should somebody care about machine learning? What are some interesting problems you can solve using machine learning? And what we will do today is look at one specific problem in machine learning and then start thinking about that problem. So I mean, it would be very nice if the session itself is interactive. So I think that's feedback for me as well, that participants are involved and I mean, are kind of taking away something from the session. So if you have any questions at any point of time, feel free to ask me, stop me at any point of time. No question is a silly question. So all questions are useful questions. If not for you, it might be for somebody else as well. So please feel free to interrupt me at any point in time. Okay, so let's get started. Maybe I'll start by asking a question to the participants here who are all in the data science program. So what is your understanding of machine learning? When I say the term machine learning, I'm sure you've heard that term so many times in the last maybe even couple of years. So what is your understanding of the term machine learning? Anybody in the audience? What does the term, this words machine learning mean to you? Anybody? Any suggestions? What would that be? Why are you interested in machine learning? Anyone in the audience? It's okay if the answer is incorrect, that's fine. You can try to answer, yeah.
I'm waiting for students to respond.
Absolutely. Yeah. So we'll wait for the students first. And maybe if the students are too shy, maybe the faculty can start and then maybe the students will pitch in. Okay, so I have some answer. How to make the machine learn? Yeah. So there are two words, machine and learning. So we want to somehow make the machine learn, which is obviously a reasonable answer and a correct answer too in some sense. But what does it mean to say we want to make a machine learn, right? So what do we want the machine to learn, and why do we want the machine to learn? Students, maybe if any of the students have any thoughts, or even the faculty, anybody who's, what is your idea of when we say we want to make the machines learn? What do we want them to learn? Machines, I'm assuming, are computers here, right? So we want the computers to learn something, but what do we want them to learn? Learn algorithms. Okay, good. Okay, so there's one more question, answer. For decision making as like human brain. Excellent, right? So we somehow are curious that we want the computers to work like human beings, and so as I think Kyle, right? So mentioned. So we want somehow to make the machines mimic the human brain, which is like the holy grail of machine learning, right? We somehow want to get there, but if I want to put a picture like this. Oh, sorry. Right. So if this is the prototypical human, so this is the brain which we want the machine to kind of mimic for us. But this is a very, very hard problem, and this is a very hard problem because even we don't know how the brain works, right? So the brain is a very complicated piece of instrument, and we, as you know, so many years of study, we still don't understand how the brain works. But it's not just the brain. We want the machine to do a lot of other things also, right? So, a prototypical human, has eyes, right? So we want the eyes are very, very, evolved organs, right? So the eyes, by evolution, the eyes have evolved over billions of years. And now they are so powerful that you just look at certain object and then immediately you can figure out what that object is, right? So the eyes get the signal. It's just an image that the eyes are getting a signal, and immediately the eyes are able to figure out, hey, this is some object. For example, this picture itself, your eyes are looking at this picture, and immediately you know that this is like a picture of a human being, right? So that I'm trying to draw. Though I have not drawn the entire human being here, I've only drawn a part of it. Still, you are able to figure out that this is a picture of a human being. So that is the power of, the evolved, instrument that we have, eyes. And we do our day-to-day activities using, inputs that the eye receives, and then the brain processes it and so on. So can we make machines mimic eyes? Right. So it is so easy for us to figure out by looking at this picture that this is the picture of a partially drawn human being. But today it's not so easy for computers to know this, right? So now all of you are from computer science department, so you kind of are aware of how computers work, right? So we write code, and then there is an algorithm that takes as input something and then output something, and there is a procedure that happens in between, right? So now we want to teach machines to do these tasks that the eyes are doing for us, or the brain is doing for us, right? So, or not just the eyes and brain, or even the mouth, right? So now we want to do text/speech processing. That's what the mouth does. It speaks, and then the ears hear, ears and mouth together hear and speak, which is basically we are able to transmit communication from one person to another using natural language, right? So, and different cultures have evolved with different languages. Even in this Zoom call today here, we have people who communicate in Tamil, we have people who communicate in Telugu, and all of us do it in English here. So, and these are independently evolved languages, and we want a computer which is language neutral to be able to figure out what it is hearing first. I mean, if I speak now, and then if you record it as an MP3 file, then we want the computer to figure out what I am speaking, which language I am speaking first. In this case, it would say, this is English that I'm speaking, and then it has to figure out, what is the meaning of the sentence that I'm speaking. So these are natural, very natural for human beings to do, but then these are super hard problems for the computer to do, right? So for example, I'm sure all of you have encountered these things called CAPTCHAs, right? So what are CAPTCHAs, and where have you encountered them? If you have heard of this term, anybody? Has anybody heard of? So if you have heard of this term CAPTCHA, can you just give your thumbs up? Mail login, yeah. So mail login, or if you want to, let's say, book an IRCTC ticket, which is one of the hardest thing to do, especially if you are booking a Tatkal ticket, and Deepavali is coming very soon, and all of us will try and move around. And if you are trying to book Tatkal tickets in IRCTC, it's going to ask you for a CAPTCHA, right? So online filling forms, online what was that? Online fee payment, whatever, right? So all these places you have filled the CAPTCHA, right? So now what is the purpose of this CAPTCHA? What are we achieving by doing this, right? So why is there something called a CAPTCHA? I am not a robot. Very good. So it has to somehow figure out that you are not a robot. What does that mean? What does that mean? Why is it? How is entering a CAPTCHA making sure that you are not a robot? Protection from remote digital entry, correct? So this is for safety purpose. Make sure only human beings can access, right? So which means what? Which means what is the fundamental problem that CAPTCHA is actually taking advantage of, right? So we read by eye, and as Dr. Vijaya says, we read by eye and then we reproduce it, which means that a CAPTCHA is like a slightly complicated way of writing a standard text, right? So it will be in some design, it will be tilted and so on and so forth. Now, it is so easy for human beings, right? So let's say I want to write hello, I might write it like this, right? This is hello too, or I might, you might find a CAPTCHA that has hello like this, right? So both of these are CAPTCHAs, and both of these are very, very easy for me to process and figure out what I have written, right? So, but if you want a computer or a robot which is trying to book all IRCTC tickets from, let's say, Hyderabad to Madurai for Diwali, right? So I might write a code which will just book, attack the IRCTC server and book all tickets, right? So from Hyderabad to Madurai, let's say, right? So now I want to stop that. So what I do is I kind of put this CAPTCHA to say that, well, if you are a code, then you better crack this CAPTCHA, right? So which means that there is an inherent difficulty for a computer to look at this image, right? So this is not text, right? So this is going to be an image that is being displayed and figure out the letters that are there in this image, right? So it is kind of difficult today for computers to do this with 100% accuracy, whereas human beings do this very easily, right? Why? Because the eyes are so evolved organs, and we have learned from experience over, from our day of our birth till today. We have seen things in different shapes and forms, and then we somehow are able to, our brain has a mental model that, this has to be the word the letters HELLO, and hence this has to be the word hello. Whereas the computer does not have such a strong mental model of the eye that it can process this and figure out what these letters are. Right. So in a CAPTCHA case, it might seem detrimental to teach the computer figure out that this is actually HELLO. Then we might ask, why should we teach this to the computer? Because we don't want computers or robots to do this for us, right? But I mean, yes, in this application, we don't want the robots to crack this CAPTCHAs, but there are other applications where you want the robots or computer to actually be able to read text and figure out what is the text in it, right? So for example, a classical example would be, I mean, nobody perhaps not many write snail mails these days, but then if you are still writing some not emails, but snail mails, I might put my the pin code. I'll write a pin code. This is the pin code where I live. So I might write the pin code like this. And now if you want an automated mailing system, right? So which figures out which letter should go to which, disbursement location, I might want to figure out what is the pin code automatically. But then this pin code is handwritten. So I might take a picture of this and feed it to an algorithm, and the algorithm needs to figure out that this is 600036, which all of you figured out because your human eye and the human brain already have a model to interpret this. But can we teach computers to do this, right? So because it will then make a lot of tasks easier, right? So this might be one application where we want to do online, handwriting recognition. Right. So where this first block the computer should figure out which of these numbers is this, right? So I have 10 choices, 1 to 9, and then there's 0. And now among these choices, by looking at this image, remember, this is not a number, this is an image of a number, which means that there are these pixel values, right? So each image is just a bunch of pixels. And now each pixel is red, green, blue, which means that this image itself can be represented as pixel values. And then by looking at these pixel values, can I figure out that this is actually the number 6, this is actually the number 3, and so on and so forth, right? So this is a typical online handwriting recognition problem, which we want the computer to figure out, right? So these are the type of problems these are some examples that I'm throwing out here that we want the computer to figure out, right? So here is another example, right? So let's say for some reason, let's say for some reason, let's say you have an MP3 audio file that Sorry, is there a chat question? Yeah. Okay. Let's say you have an MP3 file, right? So MP3 file of your favorite song that you heard recently. And if you actually look at the MP3 file, it's just a signal, right? So basically, it's just a voice plus instrument signal. And now, as a function of time, if you kind of try to plot the signal, it will be some signal like this, right? So in terms of frequency, right? So if I plot the as a function of time, I'll get some waveform like this. Now this waveform has both voice plus instrument, right? And for some reason, I look at the signal and I kind of I'm so interested in the singer's voice that I don't want the instrument. I only want to kind of extract the voice from this signal, right? So it's a mixture of voice and instrument. Now I want to learn how to separate voice and instrument separately, because I might want to only listen to the voice, or I might want to only listen to the instrument, right? So now when an actual song is sung, it's not going to be the case that the singer is going to sing and then there is going to be instrument for a while, and then the singer will sing and then there is going to be instrument. That need not be the case, right? So the voice and instrument might actually mix and play at the same time, right? So as the BGM is playing, the singer might sing and so on and so forth. And in this cases, how can we automatically break this into two different signals, right? So this signal can be broken down into a voice signal plus an instrument signal, right? So this is an instrument signal. Even in the instrument, there may be multiple instruments. For example, this can be a guitar, this can be percussion, this can be flute, whatever it is, right? So we might want to extract these separate things out from a single signal itself, right? So now this is a hard problem even for human beings, right? So it's very hard because if I give you the signal, I don't know how to process signals. But then can we use computers to do this? Can we teach computers to do these hard things that are not easy for humans, right? So in the earlier case, things were very easy for humans, but then we want to teach computers to do this. Here, this itself is hard for humans, but then can we teach computers to do this, right? So this is also a machine learning problem, right? So this is one other example of a machine learning problem. I'll give you a bunch of examples and then we'll categorize these examples more clearly. Another example would be the following, right? So let us say you are a manager of a bank. Let's say you are a bank manager, and your goal is to decide if somebody walks into the bank with a request for a loan, you want to figure out if that person should be granted that loan or not, right? So let's say that is your goal. Now, if you're a bank manager, and you have to decide, let's say some customer walks in and requests you for a loan, right? So now how would you decide to grant loan or not? So what parameters would you consider to figure out if a loan should be granted to somebody or not? What are your thoughts? Let's say somebody is asking for a loan to build a house, right? So now you are a bank manager. Now what parameters would you look at? House properties, income levels, salaries, all of these are relevant things, right? So different people are saying different things. Let me kind of note down credit history, excellent. Capacity, reliability, there are so many things. So originals, land, excellent. So let's call these things as features, right? So some features in this particular example, maybe income, maybe age is one thing. Maybe credit history. Did this guy repay his loans earlier, or is he a defaulter, and so on and so forth. There are more location, land, whatnot, right? So and so on and so forth. So let's just call these as features. I mean, your favorite features, you've already mentioned so many. Now the manager has a mental model of which is important, which is not important. And then somehow is going to look at all these values and figure out if a loan has to be given or not, right? So the goal is to map features which are input to decision, right? So in this case, let's say the decision is yes or no, right? So that is the decision that I want to make, and then I'm looking at the features to make this decision. Now, well, let's say we want a computer to simulate this for us, right? So now, what can the computer do? How can the computer figure out if, by looking at the features, should it decide to grant the loan or not grant the loan? Now, of course, let's say this is a new customer, right? So who is just walking in. This person has not taken a loan before with the bank. So you don't know whether this person will return the loan or not a priori, right? So how do you think algorithmically we can teach the computer to make a good decision, right? So what should the computer use to make a decision? What do you think? Salary, only salary, income. Okay, so these are features. So yes, so the computer is given the input all these features, but then it has to come up with a rule, right? So it has to say that somehow it has to come up with a rule that if the income is greater than something, if the age is less than something, then grant the loan, or otherwise don't grant the loan. Something like that. It has to come up with a some way of some rule to figure out the decision. But how do you decide this rule, right? So how does the computer learn this rule? From where can the computer learn this rule? What information does the bank have that the computer can use to learn such a rule? History. What do you mean, Akshaya? Very good. What do you mean by history? What history? Previous data, right? So yes, history means previous data, right? So history of the bank. So the bank has a lot of historical data, right? So in the last 5 years, there are so many people who were granted the loan. Some of them, paid the loan back. Some of them did not pay the loan back. Now the bank has an entire data, right? So historical data of people, right? So maybe there was this guy. Let's just call this guy John, whose age was 32 and salary was, I'm just making these numbers up, I don't know, so $10,000. And then this person, yes, paid the loan back, right? Maybe there is Mary, who was 30 years old, maybe had $12,000 as income, and also paid the loan back, right? So maybe there was some Harry. I'm just cooking up some English looking names, but that doesn't really matter. Maybe he was 24 years old, maybe had $5,000 income, but did not pay the loan back, right? So, and you have like tens of thousands of such historical data. Now, what you can do is, as you have historical data, history, and now you input this history to a machine learning model, which I'm going to call as ML, not model. So let me call this, instead of model, let me call this machine learning algorithm, right? So the algorithm is going to output what is called as a model, right? So now what is the use of this model? The model's use is the following. Now, if a new customer, right? So customer walks in. Now you apply the model to this new customer's features, and then you make a decision based on that, right? So let me say this again. So you have historical data, which is of this form, where these are the features. You have, the name doesn't matter, but then age is a feature. Here, this is a very simplified example where you only have age and salary as features. And then you have what is called as a label, which says whether that person, repaid the loan or not, right? So in this case, the label is just yes or no. So this is what is a bunch of historical data, sometimes also called as the training data. So you have a lot of training data, and then you give this training data as input to your ML algorithm. Now we'll see what the algorithm is a little later, but for now, let's say this is some magic algorithm that takes all this training data and produces what is called as a model, right? So the model is, we'll talk about what the model is also a little later, but for now, think of this as something that can be used to make a decision for a new customer, right? So this is a new customer. Mind you, this new customer need not be in the bank, right? So they need not be in the history, right? So this is a completely new customer. This is neither John nor Mary nor Harry. Maybe this is Arun, right? So maybe this is me, new customer who walks in, and I have my own age and salary. And then this model should be able to take any age and salary pair and should be able to figure out a decision whether which is yes or no, right? So now this is the slight difference from standard algorithms that we do in computer science, right? So in standard computer science, the algorithm is just a rule, right? So if, let's say, if you're doing a quick sort, let's say if you're doing searching algorithm, so there is no dependence on data, right? So of course you're going to give an input, and then there is a set procedure that you run to produce an output. The input might be a bunch of numbers. The algorithm takes them as input, does something, quick sort does something, and then produces a sorted list as output, right? So there is no dependence on data. Whereas here, we have to rely on previous data to understand the relationship between features and decisions, how decisions have been made historically, and then use that to make a decision for a new customer, right? So the secret sauce that separates standard algorithms that you might have seen in computer science from machine learning algorithm is this secret sauce is data, right? So you have to use previous data to learn from previous data to make good decisions for the future, right? So that is the basic idea of machine learning itself, right? So again, now this is not just for the bank example, right? So now if I go back to my previous example, so for example, in the online handwriting recognition case, now I want to be able to recognize, digits that people write. So in this case, again, my data is not going to be historical data. This is some data that I would have collected where, I might have different people writing, the number 6, and then I would map this to a label. So the feature in this case is just an image, which has the number 6 written by different people, and the label is always 6 in this case. It's all these mapped to the label 6. Maybe somebody else might write 1. I mean, we'll collect data about 1, and then people write 1 in 100 different ways, right? So all these have label 1. 1, 1, 1, 1. This is the number 1. This is the image 1, right? So different ways of writing 1 we collect from different people, and then we say, hey, all these correspond to 1, all these correspond to 6, and then you collect something similar for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have a huge data set, and now what you want the machine to learn is a mapping, a model that now given a new image of somebody who's not there in my data set, should be you able to figure out what this image is, right? So which number this image has. It's the same idea, right? So you have some data, you train some machine learning algorithm using the data. What is the algorithm we'll talk about today later? But let's say there is some algorithm that takes the data, does some training, and outputs a model. And now for a new image that might come into the system, now you figure out using the model, you make a prediction for this, right? So now in this case, the prediction is not a 0 or 1, right? So as we saw in the previous case, here the label was yes or no. There were only 2 possibilities, whether the loan can be given or cannot be given, whether the loan was given, whether the person repay the loan or not repay the loan, right? So there are only 2 options earlier. Whereas in this online digit recognition case, you have not just 2 options, but then you have 10 different options. Is this image, does it contain a 0 or a 1 or a 2 or a 3 or a etc. Until 9, right? So there are 10 possibilities. So one is called as Dr. Vijaya points out correctly. So what So this problem is what is called as a binary classification problem. And I'll again come back to this because it's binary, because there are only two labels possible, yes or no. Whereas this problem is what is called as a multi-class classification problem, because there are not just two, but then there are 10 different possibilities for each image, right? So it can be any one of 0 to 9. So both of these problems, so now what we are going to do now is kind of categorize different machine learning problems into different buckets, and then look at some examples of those, right? So I want to look at machine learning problems. And now broadly, these fall under two different categories. Some of examples I've seen, now I'm trying to bucket them into proper sets. One is what is called as supervised learning, and the other is what is called as unsupervised learning, and we'll talk about what these two things are now. Right? So in supervised learning, in both of these cases, you want to learn from data. Data is the secret sauce of all machine learning problems. You will learn from data only. Now, what type of data do you learn from determines whether it's a supervised learning problem or an unsupervised learning problem. In a supervised learning problem is what we have seen examples. So the data, what decides whether a problem is supervised or unsupervised? Well, what type of data you have? In a supervised learning problem, your data contains two things. One is features, the other is labels. Which means if it is a bank loan prediction problem, you have income, you have salary, you have credit history, all the features, and you also have supervision. Somebody comes and says, hey, this person, John, had this age, this salary, this credit history, and the label is he did repay the loan back, right? So the decision is also given to you, right? So as part of the historical data. Similarly, in the online digit recognition problem, you are given, hey, these are the images, different images of people writing numbers, and then this image corresponds to number 6. This image corresponds to number 0. This corresponds to number 1. You are also given supervision as to what the labels corresponding to the features are, right? So in the bank problem, the features are discrete features, right? So income, salary, etc., etc., etc. In the online handwriting recognition problem, the features are the images itself, right? So the image itself is the feature. The label is one of the numbers between 0 to 9. Now, under supervised learning, you have multiple possibilities. We'll talk about that and then come to unsupervised learning. One is what is called as, let me make this clear. One is what is called as a classification problem, where the labels are discrete classes, right? So, for example, this can be binary classification, where as an example, one example that we saw here was bank loan problem. Another example could be, you might have a lot of emails at your disposal, and then some of the emails, maybe somebody comes and says, hey, these emails are labeled as spam emails. Some of the emails are labeled as non-spam emails, right? So I'm sure all of you use emails, and if you go to Gmail, there is on the left-hand side, you will find a spam folder where unnecessary emails are automatically go to that spam folder, right? So now, how does Gmail know that what is spam, what is not spam, right? So you never told Gmail that this is a spam email, this is a non-spam email, but then automatically that email goes to the spam folder, right? So which means that there is a machine learning algorithm sitting inside Gmail which looks at every email and figures out whether this should be given push to the spam inbox or the normal inbox, right? So now how did this algorithm, how did they come up with this algorithm? Well, what Google would have done is they would have taken hundreds and thousands and millions of emails and then manually labeled them as spam emails or non-spam emails, right? So somebody must have looked at those emails and then said whether, not your emails, but somebody else's emails, right? So in general emails, and then figured out whether they are spam emails or non-spam emails. And now from that, Google would have trained a spam classifier, which now a new email comes, it automatically predicts whether it should go to the spam box or a non-spam box. The decision is still spam versus non-spam. There are only two possibilities. And so that is also a binary classification problem. Binary means two, right? So email spam classification. That's another example of a binary classification problem. But labels may not be just one of the two possibilities. There can be multiple labels as we have seen. So that in the handwriting recognition problem, there might be something like a multi-class classification problem, right? So handwriting recognition. To figure out if an image is one of the 10 possibilities. So can you think of a different multi-class classification problem where you have to decide between not just two, but then more than two possibilities? Any thoughts, any examples? Any problem where you want to figure out more than two classes? So let me give you a slightly object recognition by sensors. Definitely there are multiple objects that might be there. Animal type recognition, very good. So you might want to classify an animal as one of the different types. Yes. So slightly fruit shape, sure. What type of fruit is it might be one thing. Or let's say there are many students here. Let's say, all your faculty now decide to use a machine learning algorithm to grade your answer sheets and give you, grade S, grade A, grade B, grade C, grade or D grade. Now, let's say a machine is going to do that, right? So because we faculty get bored correcting papers, so let's say we use a machine learning algorithm to do that. So now it has to, read. I'll just give a scanned copy of whatever answer sheet you submit. And then the algorithm looks at that image and then automatically figures out, which grade you should be granted. I'm just kidding. So we are not going to do that any soon. But yeah, if you did that, then that would be a multi-class classification problem, right? So where you would have to classify your answer sheets to one of the 5 different grades, A, B, C, D, E, let's say, right? And you've given me so many examples, so you get the drift of what multi-class classification is. Now, let me ask you one more. Let me give you one more example where now in this example you. So the problem is let's say rainfall prediction, right? So now I don't know how many of you follow the World Cup. Now Cricket World Cup is happening, and then we want to predict whether it will rain or not. And how much will it rain, so that we have to, a priori decide whether the match should be conducted at, let's say, Vizag or Chepauk or somewhere, right? So in whichever place that the players play. Now, here again, there might be a lot of features, right? So what might be some features that might predict rainfall? I think, yeah, sure. Kavya Shri is giving the answer for the previous question. Yes, you are right. Fingers recognition by sensors. Yeah, for the rainfall prediction problem, what might be some features? You want to predict the amount of rainfall that will fall on today or tomorrow, let's say. You want to use historical data to make a prediction. So what kind of features would you like? Let's say if you are the meteorological department, what kind of features would you use to make this prediction? Humidity, season, great. Humidity, temperature, pressure, precipitation, whatnot, right? So I'm just I'm just cooking up some features, but yeah, so these are all features. Now the label is going to be how much did it rain, right? So the meteorological department has collected all the information for the last 5 years, and it has also collected how much did it rain in each of these days, right? Now, how much it rains is a number, right? So maybe on one of the days it rained, maybe on one of the days it rained, 180.3 centimeters. Maybe another day it rained 150.7 centimeters. I'm again cooking up these numbers. Other day it did not rain at all. That was 0, right? So there is some number of in centimeters that you can measure the amount of rainfall, and this differs in every single day, right? So now for a new day, right? So for today, let's say I collected humidity, temperature, and precipitation, and I want to make a prediction. How much will it rain? Not whether it will rain or not, rather how much will it rain, right? So the number. So now, would it be a binary classification or a multi-class classification problem? Would it be one of these? What would it be? Anything that we have seen so far, or would it be something new? Why it is something new, but why? You're right, but why is it something new? What makes you think that it's not binary or multi-class, but something new? Well, what are the possible choices for labels, right? So here the possible choices for the label was yes or no. Here it was spam or not spam. There are only 2 possibilities. Here it was 0, 1, 2, ... till 9. There are 10 possibilities, right? Yes. So as correctly mentioned by Neeli Manisha, so she says this is not restricted to a subset of values, right? So this rainfall can be any number, right? So it can be 180.3, 123.82. It can be any number, right? So it can be any real number. But still, this is a supervised learning problem because we have collected not just the features, but also the amount of rainfall for the last 5 years. So there is supervision in terms of label, but then the label is not discrete, right? So it's not one of the small, discrete, finite set of values. It can be potentially any number, any positive number. So when you have labels as not just a single, finite set of numbers, but then it can be any number. So then we call such problems as regression problems. Right. So these problems are called as regression problems. So as an example, this can be rainfall forecasting. This is an example of a regression problem, right? So can you give me a different example of a regression problem where you might have to predict any number, not just a number in a finite set? Chandrayaan 3, great. What is the problem that we are trying to predict there? What is the problem in Chandrayaan 3, which is a regression problem? Sales and promotion forecasting. Okay. So what might be that's a good example. I think the name is Tanvita, is that correct? Yeah. So what might be features there, Tanvita? I'm sorry if I'm saying your name incorrectly. Share market. Yeah. So that's another example. But maybe I'll look at the sales first and then come to share market. Yeah. So what are the features there, Tanvita? Tanvita Shivani. Yeah. In the sales and forecasting. So sales forecasting problem. What will you use to do sales and promotion forecasting? So basically, I'm assuming you want to figure out how much, let's say you're Amazon, right? So you run Amazon, and then you want to figure out, there is this big billion sale coming up for Diwali, or I don't know for what, in a few days, maybe in a week or two, and then you want to figure out, or Navaratri, I guess, right? So, and you want to figure out how much of a particular product will get sold, right? So how many units of a particular product will get sold. Now, that is a regression problem because it is one of the numbers, or maybe you want to say how much money will you make by selling these products, right? So, on different point, you might price it differently. So, you want to predict the exact amount of money that the product will, yield you. And that is a number which is not necessarily one of the finite quantities. So, that is a regression problem. But what might be the features? Like how for rainfall, humidity, temperature, precipitation might be features. What might be the features? Marketing, yeah. So historically, you might have, this. So different types of, it might be as simple as, how many were created, how many were produced. That was one thing, because that might decide how many will get sold. Yeah, data during different periods of sales, right? So because in different seasons, different products get sold differently. It might be as simple as, which part of the page are you displaying this product, right? So, I mean, we never know, right? So psychologically, cognitively, we might be clicking on the left side of the page more than the right side of the page, right? So I think that's a huge study that people do in human computer interface research, where should you place the product so that, I'm more likely to click and buy that product, right? So subconsciously, we might have bias. If you're a right-hander, maybe you're scrolling more on the right-hand side of the page, or so on and so forth. We don't know that. Right? So all these are perhaps relevant features to make decisions about, sales forecast, let's say, right? Similarly, for stock market, you might want to predict how much exactly will the stock price go up or go down, right? So then you can make decisions to sell or buy that stock price. That's also a fair example. Okay, so these are three broad categories of supervised learning problems, which are binary, multi-class, and regression problems. The difference is in the number of labels that you have. In binary, it's 2. Multi-class, it's more than 2. Typically, in regression, it's infinite. Now, this is the supervised learning part. Again, just to remind you, supervised contains features and labels. Somebody gives you not only the features, but also gives you supervision saying, well, what decision that this label corresponded to historically. Unsupervised learning. Now you should be able to guess what is unsupervised learning because there is no supervision. That's the difference, right? So, but where did the supervision come from? It came from the labels, which means that in unsupervised learning, the data contains only features, right? So that's the only difference. The data contain only features, and now you don't have labels, right? So now you want to basically somebody gives you a bunch of emails and then asks you, hey, go make sense of this bunch of emails. You have 10,000 emails with you, but you are not told which emails are spam, which emails are not spam. That information is not given to you. Which means that only if that information is given, and if your task is to figure out a new email is spam or not spam, then you can run a supervised learning, post it as a supervised learning problem. Now you are not given the labels, right? So you're only given a bunch of emails, which is each email is just a text document, if you want to think of it that way. And now you want to figure out the task is unspecified, right? So the task is typically unclear in unsupervised learning. One task might be to say that, can you kind of group these emails such that emails in a group look similar, right? So that is something what is called as a clustering task, right? So you want to kind of say that, these are one group of emails, these are one group of emails. Now, if you may want to then, it might so happen that you might have emails which are personal emails from your family and friends. There might be emails that are work-related emails. There are emails that are, promotion-related emails, and so on and so forth. Of course, you don't tell historically which is personal email, which is work email. But then the nature of the words, the nature in which text is written might be enough to figure out that, all the personal emails might have, hey, how are you, kind of a thing, right? So more casual tone, but then all the work emails might have a more formal tone. And then can we automatically figure out groups of emails without being told which email belongs to which category, right? So doing that is what is called as unsupervised learning. I mean, maybe over the course of this course itself, you will learn about unsupervised learning from other people. So I'm not going to touch too much into that today, because our goal today is to kind of briefly talk about supervised learning. And specifically, I want to talk about the problem of regression, right? So my goal was to introduce the high-level problem of machine learning, categories of machine learning, and then talk about one specific problem. And for today, I will take the problem of regression and talk about that. So that's what we'll do in the next maybe 45 minutes or so. But let me pause here and kind of ask you if there are any questions or any comments at this point. Anything that we have discussed before I move ahead. Or any doubts in whatever we have seen so far. Anything. Okay. Okay, so there is a question. What is the difference between multi-class classification and cluster? Okay, so the difference is the following, right? So multi-class classification falls under classification, which falls under supervised learning, which means that in data, whatever you collect has features as well as labels, right? So somebody tells you that, so let's take a very simple example, right? So let's say this is the data that you have. I'm going to hook up this data in a specific way. Let's say I have 4 images. Right. So in a multi-class classification problem, let's say I might, in this simplified simplified problem, I just have 4 images. This is image 1, image 2, image 3, image 4. And now I'm telling you the first image corresponds to label 6, second 2, third 6, and fourth 2, right? So now you might get a test image like this. So this is a test image, a new image, which I want to figure out. This is the training data. This is what is called as a training data. And now I have a test image, which looks like this. And now I feed this to my algorithm or a model, which kind of, I should not say algorithm. Let me be precise there. I'll say this as my model. And then the model has to predict this is 6 or 2, right? So this is a multi-class classification problem that we have seen so far, right? So of course, I have only 2 classes here. I might have multiple classes later on, right? But now in a clustering problem, what I am given is, I'm not given these labels, right? So this is no longer my problem of interest. I'm not given this label. I just have this bunch of 4 different images, right? So 4 images in this data set. Now I am asking you to group these images in whichever way the algorithm feels makes sense. Now, how do you think the algorithm can group these images? So again, let's say this is image 1, 2, 3, and 4. If I want the algorithm to separate this into 2 groups, which one will fall in which group? By checking similarity, correct. But in this case, let's say if you do the checking similarity, so there is group 1, there is group 2. Which images will fall in group 1 among 1, 2, 3, 4, and which in group 2? Let's say what would be your answer if you had to separate this into 2 groups? Okay, 1 and 3 in group 1, 2 and 4 in group 2. Why is that? Why are you saying that? Because 1 and 3 have the number 6, but then 2 and 4 have the number, they look alike. But now there might be somebody else in this audience who might say, well, I don't know these are 6 and 2, right? So I'm a computer. I'm just looking at these as some pixel values. And Akshaya doesn't agree with the others. Akshaya is looking at the color and says that, 1 and 2 are in one group, 3 and 4 are in another, right? So Balaji is also saying that, right? So based on colors. Now, this is also a valid grouping, right? So 1 and 2 have blue color, 3 and 4 have red color, right? So now if you look at the pixel values, they are going to be different, similar in terms of colors for 3 and 4, right? So there is no single ground truth that tells us that this is the right way to group things, right? So if you don't have labels, you run into that problem. The moment I have labels, then I know the problem is very clearly defined, right? So I know that this is 6, this is 2, this is 6, this is 2. So then my goal, the algorithm would learn something that does not depend on color because the labels are given, right? So it's a supervised problem. But it's unsupervised, there are multiple ground truths. So we have to be a little bit more careful to decide what is correct, right? So that's the difference. I hope that was clear. Yeah. Any other questions? Okay. If there are no further questions in this part, so let's move on and talk a little bit more, dive into the details of the problem of regression, right? So which is going to be our focus for the next some more time. Regression. Maybe I'll use a different color so that it's clear. Okay. So as I said, regression is a supervised learning problem where you have features and the labels are typically not discrete values. They can be real values, right? So they can be any real values. We'll take a simple prototypical example and then I'll try to motivate the problem of regression with this. And then we'll see how to come up with algorithms to solve this problem and so on and so forth, right? So let's imagine this situation where you go to a store and every day you, for whatever reason, you want to buy 3 different things, right? So you want to buy apples, oranges, and let's say mangoes. Let's say you decide to go on a fruit-only diet for the next 1 month for whatever reason, right? So maybe you saw on Instagram that it's good to eat only fruits. Don't take my advice as medical advice or anything. It's just cooking up an example. And then you decide to eat only apples, oranges, and mangoes every single day, right? Now you go to different stores on different days, let's say, right? So you don't go to the same store on every day. Now in the first day, let's say you bought 3 apples, 1 orange, and 2 mangoes, right? So let's say this is what you purchased, and the bill amount, let's say, came out to be 40 rupees. Okay, so you paid 40 rupees and came back. Now, on the second day, you go to a different store, let's say. Now you got 2 apples, 3 oranges, and 1 mango, let's say. And then let's say you paid 35 rupees. On the third day, you buy 1 apple, 1 mango, 1 orange, and let's say you paid 20 rupees. Right? So now these stores are not like proper stores. They don't give you a typed bill or anything like that. They just will tell you the total price, right? So the total price is, the first day it's 40, and the second day is 30, and the third day it's 20. Now, the next day, you want to go and buy, let's say 2, 3, 1. You want 2 apples, 3 oranges, and 1 mango. Now you want to decide how much money you should take, right? So suddenly you ask the question, how much money should I take? You have this historical data, but you don't know the price of apples, oranges, or mangoes. You only know the bill amount, which is something that you have remembered for the past 3 days, right? Now, how much money would you take in this example? You don't want to take, end up taking less money and then cutting a sorry figure in front of the shop owner, right? So let's assume that you want to know how much exactly. Average amount. Okay, so average, you're saying average of these 3, I believe, right? So, but why? Why is that? So let's say now suddenly, instead of 2, now some of my friends are also coming home and they are also fruit lovers. Let's say I want this 20, 30, 10, right? So I want to buy a lot of apples, oranges, and mangoes, right? So would you still do the average? What would you do? So can you guess the price of apple, oranges, and mangoes? Can anybody guess the price from these 3 days information? Okay, Akshara says 6. Very tricky, no answer. There is an answer. Akshara says 6 and 6.6. What is 6.6, Akshara? When you said 6.6, what did you mean? What was 6.6? 20 by 3. Where is 20 coming from? Which 20 are we talking about? Oh, I see. Okay. So you're saying, so the total when we, based on third day, we bought 1 apple, 1 orange, and 1 mango, and then the bill was 20. And so, well, why does that mean that apples and oranges and mangoes don't have to be of the same price, right? Well, not all fruits are of the same price, right? So maybe if I change mangoes to, I don't know, what is the costliest fruit? Strawberries, I don't know, something like that, or even I don't know, some expensive fruit. It may not be the same price, right? So the prices might be different. So we cannot decide just because the sum of apple, orange, and mangoes is 20, each of them have to be of the same price, right? So that's not necessarily true. How do we find this? So what do we need to figure out the answer for the last day? What information do we need? What information are we seeking? Price. We need to know the price of a single apple. We need to know the price of a single orange and a single mango. That's the information that we are seeking, though we don't have that information, right? So if we know that, then we are done. But what we have is this data, which tells us, this group of values price is something, and we want to figure out based on that. How do we figure that out? How can we figure it? Yeah, price of each is what we want. So just to go with the logic of, I think, Akshara. So if each one had value 6.6, which is 20 by 3, then what happens to day 2? That would be 2 into 6.6 plus 3 into 6.6 plus 1 into 6.6, right? So because each one is 6.6 according to what you're saying, so that would be 6 into 6.6. because 2 plus 3 plus 1 is 6. But 6 into 6.6 is 36 plus 3.6, 39.6. I would have actually spent 39.6 if that was the thing, but then I only spent 35, right? So 6.6 may not be the correct answer, isn't it? So what then would be the correct answer? Statistical analysis, yes. In this, we are not yet in the statistical analysis realm yet, but there is a simpler way to figure this out. So let me make this question a slightly simpler, right? So let's just look at apples and oranges only, right? So let's not worry about mangoes for the moment. Let's say 3 apples, 1 orange. I mean, this is a different problem. Don't worry about the previous problem. It's a simpler problem, let's say, is 25, right? So the bill is 25. Let's say 1 apple and 2 oranges. Well, maybe 1 apple and 4 oranges. Is 45. Now I want 10 apples and 10 oranges. How would you solve this? So what is the price of apple and what is the price of 1 orange? Any guesses? So let's say the price of apple is some A and price of orange is B. Then what does 3 apple and 1 orange equal to 25 means? Okay, Yuvatini says orange is 10. Anto, okay. So Anto says 3x plus y is 25, right? Apple is 5. Okay, great. So somebody, I think you guys figured it out. Now Anto says is giving us a more, principled way to figure this out, right? So if apple is A and orange is B, we don't know what A and B is, but we know that 3 times A plus B is 25 because 3 apples plus 1 orange is 25. And 1 apple plus 4 oranges is 45. Right? So we know both these equations. Right? So now we have to solve for A and B. How do you solve for this? Any thoughts on how to solve this? Subtracting, right? So you have to subtract such that one variable kind of goes away. So if A plus 4B is 45, now we also know that, or rather I can subtract. So 3A plus 3 times 4B is 3 times 45. Right. So now I can subtract equation 1 from equation 2. So 2 minus 1 would give me 3A minus 3A plus 12B minus B is 45 into 3 is 135 minus 25. Now this will tell me 11B is 110. So B is 10. Well, the price of orange is 10. Now, if the price of orange is 10, then we can substitute it back to one of the equations. 3A plus B is 45. We already know the price of orange is 10. So 3A plus 25. We already know the price of orange is 10. So 3A plus 10 is 25. So 3A is 15. Now that means that A is 5. So apple is 5 rupees, orange is 10 rupees. I'm sure all of you, kind of have seen solving equations from your whatever, like 10th standard, right? So it's not a quadratic equation. So a quadratic equation would mean you would have A square or B square, right? So only then it's quadratic. So this is what is called as a linear equation. It's linear because, why is it linear? So 3 apples plus 1 orange is 25 rupees. Right? So now, even without knowing the apple price and orange price, if I asked you how much is 6 apples plus 2 oranges, what would be the answer? So first day I go 3 apples, I get 1 orange, I pay 25 rupees. If I have 6 apples and 2 oranges, how much will I pay? Should I pay? ₹50, right? So you have to double this. Why is that? No, I double the amount of each of these guys, and then the answer also doubles, right? So if the input doubles, the output doubles. If I scale the input by something, the output also scales by the same amount, right? So now that is the property of a line, right? So now if this is a line, at 1, this value is, let's say, 5. If I go to 2, this value will be 10, right? So if the input x-axis doubles, the f of x, the y-axis also doubles, right? So this property is there only for a line. So any function where this happens is a linear function. Linear comes from line, right? So the relation is, that's why they are called as linear functions. So if the input doubles, the output doubles, right? So if input scales, the output scales by the same amount, and those are called as linear equations, right? So forgetting all that, so basically the main point, directly proportional, right? So proportional, linearly proportional, right? So proportionality is typically linear, but you might have a quadratic equation which goes like this, right? So for 1, it might be 1. For 2, it might become 4, right? So now the input has doubled, but the output has quadrupled, right? So there is no linear relation here, right? So if the input doubles, only if the output doubles, it's a linear relation. Otherwise, it's a non-linear relation. In this case, it's a quadratic relation, so on and so forth. But that's beyond our discussion, right? So for our discussion, the main point is that, now what am I saying? I'm saying that, well, if I know these 2 days information, doesn't matter how many apples and oranges I bought in each days. If I know the labels, which are the bill amount, then I can solve this for any day, right? So I can get this, I can solve this for any day. I know the exact bill amount on any day that I want, right? So because I can solve these equations, and then I can get a value for apple and orange. Now we are going to introduce a twist to the problem, but before that, let me pause. And is this so far clear? Or are there any questions? Okay, great. Clear, great. Okay. So now let me add a twist to this problem. For that, let us take perhaps a simpler example, and then I'll add a twist. Again, we are in the apple orange world only. Right. So, and then the bill amount. Let's say I got 1 apple and 1 orange, and I paid 15 rupees. And I got 2 apples and 3 oranges, and then I paid 35 rupees, right? So can somebody work out what is the value of an apple and an orange for this problem? So it's not a hard problem. I strongly encourage you to try this out and tell me what the answer for 1 apple, price of an apple and an orange is. Apple is 10. Great. That's correct. What about orange? Apple is 10 and oranges. Orange is 5. Excellent. So that is correct, right? So orange is 5. So this is correct. Great. So now you know how to solve this problem. Now I'll introduce a twist. So now the twist is that you are not going to the same shop every day, right? So these are different shops. Again, you went to the first shop, you paid 1 apple, 1 orange, the bill was 15. On a second day, you go to a different shop. Now you got 2 apples and 3 oranges. Let's say it was 34. You paid 34. Now you want to buy 1 apple and 5 oranges on the third day, right? So how much would you pay here? If you, in the previous case, if you wanted 1 apple and 5 orange, 1 apple is 10, 1 orange is 5 rupees. So this is 10 plus 25. You would have, you know that you have to take 35 rupees, right? So 5 into 5 plus 1 into 10, that is 35. But now here is a different setup. So now what would you do? So how much would you take? Rather, what is the price of apple and what is the price of orange? Well, let me actually, apple is 11, okay. And orange is 4. Okay, so somebody saying apple is 11 and orange is 4. Now let's try to do that. The first day, then how much should I have paid? 1 into 11 plus 1 into 4, which is 15. And the second day, I should have paid 2 into 11 plus 3 into 4, which is 22, 34. Okay, so in this case, it worked out. Okay, so let me change my example slightly to make sure it is slightly different. So let's say I go on a third day as well. So let me make this second day a little easier, like how we had earlier. I think we had this is what we had earlier. Yeah, 2, 3 is 35. Okay, so let's say now this is the question, right? So I do this for 3 days, and I observe that these are 3 different stores. First day it was 15, the second day is 35, third day it was 26. Now how much is 1 apple and 1 orange? Still, I'm interested in, buying 10 apples and 15 oranges on the fourth day, and I want to figure out, how much to take money, how much money to take. Okay, Anto says apple is 11. What about orange? Orange is 5. Well, if apple is 11 and orange is 5, on day 1, I should have paid 16, right? Not just 15. Okay. Sarah says we can't say. Rishita says we can't say. Why can't we say? What can't we say? Because there is no pattern. Okay. I agree. So basically what you're saying is that there is no value for apple and orange where all these, 3 days you will get exactly the same bill value, right? So that's what you're essentially suggesting. But then this is the reality of the world, right? So because I've gone to different shops, this is the data that I have collected. I still have to solve this problem, right? So if your world was like this, if you are going to the same shop every day and the prices don't change at all, then you are good, right? So you can, how to subtract equations and solve for it. But now the real world is seldom like that, right? First day, you go to the shop, second day you might go to a different shop, or maybe the prices in the shop has changed, right? So there are several factors that might lead us to the problem that there is no single value of apple and orange which will fit all the bill values that I've observed in all the historical data. But that doesn't mean that I can put my hands up and say that I won't solve this problem, right? So that's giving up. We still want to solve this problem reasonably well. So what can we do here? What do you think you would do in this situation? this is the crux of the machine learning problem, right? So, okay, combinations. What do you mean by combinations, Sangeeta? What combinations are you talking about? According to the latest price, we can predict the price. Oh, okay. So only any 2 days. But then that means that you might miss out on some information, which was critical for the previous day, right? So now think of this as not just 3 days, but then we have like 10,000 days information. And the last 2 days, something bad happened. You went to a store which was the shop owner was trying to cheat or something like that, right? So those 2 days price may not really be representative of the entire population, right? So you cannot simply say that the last 2 days are enough to make this prediction and throw away the rest of the data, right? So that may be a bad idea, because the last you might be unlucky, you went to a wrong shop the last 2 days, and your bill amount may not be really reflecting what is the truth. So it's bad to throw away data. This is a general rule in machine learning. You have data, it's better you use all the data somehow or the other. So how can we use all the data and still reconcile ourselves to find out one price for apple and one price for orange? How can we do that? What would be your method to achieve that? From standard deviation and mean, we can predict of how do you do that, madam? So if you have, of course, I can calculate standard deviation of apple and orange. That but then how will I use that to make my prediction? That will be just a single mean number and single orange number. So let's ask ourselves, what is the fundamental problem here, right? So the basic problem is the following. I want to assign some price to apple and I want to assign some price to orange. In an ideal world, that assignment of price to apple and orange will match the bill value exactly on all days. That's the ideal world, idealistic world, which is not reality. Now, when that does not happen, I still have to assign some price for apple and orange. Not all days are going to match exactly. But then what should be my goal? How can I change my goal? My earlier goal was to match all bills exactly. Now that's not going to happen. Now how can I change my goal so that I still do something meaningful? I have to give up on exactly matching the bill on all days, right? So there is no other way I can find a value for apple and orange and say that that is the best possible that I can do. I have to give up on the notion that the bills have to get matched exactly. But I don't want to give arbitrary values. I can give a range, but then, I really want to figure out a single value, let's say, right? So I want to find out one number that will decide how much money I need to take, right? So what number, I have to decide on a single number. Now I want to ask, what is the best numbers for price for apple and orange that I can decide? Well, what can I do? I can say that the prices should be such that the bills are matched as closely as possible. If possible, match the bill values exactly on all days. If not, match them as closely as possible on every single day. That's the best I can do, right? So now we have to give up on the notion that we are matching the bills exactly, but we have to match it as closely as possible. What do you think that might even be, right? So to matching as closely as possible in this setup. Occurrence of same values can be taken. That means what? I didn't understand that. So what do you mean by that? So here is what I am trying to say, right? So first day, I had one apple and one orange, right? So I want to fix some price for apple and orange. In an ideal world, this will be equal to 15, right? So it will be exactly equal to 15. Now it's not going to be exactly equal to 15. It may or may not be exactly equal to 15 for the choice of A and B that I make, right? So what I'm going to do is make how I want to measure how bad is my choice of A and B, right? So with respect to this 15, I'm going to measure it as follows. I'm going to say, this is my predicted price on day 1. If I put A and B, this will give me A plus B, and that would be my predicted price for day 1. But the actual price that my bill says is 15. Now I will look at the difference between these two and then square it, right? So if my prediction is also 15 for some choice of A and B, then this difference is 0. So I don't lose anything. If not, I'm off from the bill by some amount, and that amount I'm measuring as, the difference squared. Why squared? Because I want a positive value, right? So I'll talk about squared in a minute. So this is on day 1. On day 2, now if for my choice of A and B, I would have predicted 2A plus 3B, right? So because it's 2 apples and 3 oranges. But my bill amount says 35, right? So the difference is 2A plus 3B is my prediction. 35 is the actual value. So I want to see how much I'm off from this on day 2, right? So this is the difference between my prediction and the actual on day 2. This is on day 1. And now on day 3, it's going to be A plus 3B because it's 1 and 3. This is what I would predict, but the actual is 26. So now I want to look at the difference squared. Now, this is what I'm going to call as the loss of the value A comma B. If I choose some A and B, then for that choice of A and B, let's say A is 5 and B is 10, right? So this loss is I'm going to calculate the loss like this, right? So for instance, if I say loss of A is 5 and B is 5, let's say I want to fix A is 5 and B is 5, right? So which means that if I want to guess that the price of apple is 5 and the orange is 5, then that means that on day 1, I would have paid 10. I would have predicted that my payment is 10. On day 2, it would be, 2 into 5 plus 3 into 5, that's 25. On day 3, it would be 1 into 5 plus 3 into 5, that's 20, right? So my predictions would be 10, 25, and 20. But then the actual value is 15, 36, and 26. 35 and 26. So I'm going to suffer a loss of this much, which is 5 squared 25 plus 10 squared 100 plus 6 squared 36, right? So this is like 161. This is the amount of loss that if I make the choice that apple's price is 5 and orange price is 5, then I suffer a loss of 161 with respect to my historical data. Now, if you can give me a different value for apple and orange, which will suffer a smaller loss with respect to my data, then I would prefer that because I'm matching my bills even better. Can you give me a better choice for A and B for this data? What might be a better choice than 5, 5? Is the idea clear? What I'm trying to do as loss here? 5, 3. Okay, so let's try 5, 3. If it is 5, 3, so this is 5, 5. So Sandhya is suggesting 5, 3. Sai Durga is suggesting 11, 5. We'll try both of these. If you do 5, 3 on day 1, I would predict 5 plus 3, 8. Day 2, I'll predict 10 plus 3, 13. 10 plus 9, 19. On day 3, I'll predict 5 plus 9, 14. Whereas if you go with Sai Durga's guess, 11 and 5, on day 1, I'll predict 16. On day 2, I'll predict 22 plus 15, which is 37. On day 3, I'll predict 11 plus 15, which is 26. Right? So now, as you can already see, I can do the calculation, but then you can see that 16, 37, 26 matches these guys 15, 35, 26 more closely than 8, 19, and 14. Right? So is there a so let's try to find out the loss of what Sai Durga says, which is 16. Actually, it's 15. So the difference squared will be 1. Plus on day 2 is 37 and 35. The difference is 2. The square will be 4. Day 3, 26 and 26. There is no difference. So that is 0. So the loss of Sai Durga's guess is only 5. Whereas the loss of 5, 5 was 161. This is a huge loss, right? So with respect to matching the bills. Whereas here the loss was just 5, which is a much better guess, so to say. Right? So is there a better guess than 11 and 5 that somebody can come up with? 5 and 10, you can check, madam. It will work on day 1, you will get 0. But then day 2, you will get 40, which is already 35. The difference is 25. 5 square is 25. So you have already lost to Sai Durga in that example. So is there anybody who think they can come up with a better A and B that is better than what Sai Durga says? There is a better answer. Can somebody guess that? Whoever gets that, your faculty will give you a prize. I can't because I am elsewhere. There is I'm saying there is something better than 11, 5, a better way to fit the bills. Okay, so how about let's say, how about 10, 5? What happens when it is 10, 5? What would be the prediction on day 1? I need your help in figuring out the answer for 10, 5. Right? So 10, 5. What would I have predicted on day 1? If apple is 10 and orange is 5. 15, I would have predicted 15, which means the difference is 0. On day 2, what would be my prediction on day 2? $35, correct? So the difference is 0. So I'm okay on day 2 as well. What about day 3? The loss is 1. Excellent, Yuvatini. Because on day 3, I would predict 25. The difference is 1. 1 squared is 1, which is smaller than 5. Right? So Sai Durga's answer was good, but then there is a slightly better answer. Right? So there is an answer which is 10, 5. So my best guess probably would then be, in this case, I would predict apple is 10 and orange is 5. Right? Now the question is, we cannot go around asking people for their guesses and then trying this out, right? So we want a principled way to figure out what is A and what is B in general, right? So I want to write this algorithmically, right? So I want to type a code in my computer which will automatically take the input as my data set, which has apples, oranges, whatever, right? So, and then the bill amount, and that algorithm should output A and B, the best possible A and B among all possible A and B, right? So I don't know if 10, 5 is the best answer. Maybe there is a better answer, which I don't really know, right? So maybe 10.1, 4.9 might be a better answer, right? So I don't know. I haven't tried this out, right? So now I want a method to automatically figure this out, right? So there is nothing stopping by saying that Apple's price cannot be 10 rupees and 10 paise, for instance, right? So, or I mean, fractional prices, if you allow fractional prices, there might be better answer also. we want an algorithm to do this automatically for us, right? So, so the machine learning, the regression problem that the simplified form of regression that we spoke about today, is the problem of finding the best values for each features whose combination will explain the label in the best possible way, right? So now instead of saying apples and oranges, I can think of these as feature 1, feature 2, and I might have 100 different features, right? So feature 1 to feature 100, and then I might have a label, right? Now I want to find out some weights, whatever we were calling as price of apple, price of orange, and so on. I can generalize that and say that I want to call that weight of feature 1, weight of feature 2, and weight of feature 100. If you have 100 fruits, then it will be 100 features, 100 prices. That will best explain my label, right? Now, which means that the best weights that explain the labels is what we seek, right? So that is what we seek in a regression problem, right? So what do you mean by explain the labels? Well, explain in the labels means the loss is as small as possible. Right? So now what is the loss? The loss is, W1 F1 plus W2 F2, where F1, F2 are the features, dot plus W100 F100 minus, let's say I call this Y, right? So let's say, okay, let's call this Y square, right? So this is what I'm defining as the loss. So these F1, F2 are our number of apples and number of oranges that I bought. If there are 100 fruits, 100 different numbers. These W1 to W100 are what I want to find out. But then this is not just for one day. I might have 100 different, let's say 10 different days data. So I want to add that as some value I here, right? So I is the ith day, right? I equals 1 means first day's data. I equals 2 means second day's data. Y1 means first day's bill. Y2 means second day's bill amount. And then I want to sum it up over all i's, right? So I equals 1 to, let's say, 1,000 days. If I have 1,000 data points, I have 1,000 days. And now I want to find that choice of W1 to W100, which makes this quantity as small as possible. Right? So this is exactly whatever I wrote here, but then in more, mathematical notation, but it's in English, it's exactly the same. Right? So this is my predicted value. This is my prediction. This is actual. And I am looking at the difference squared, and then I'm summing it up over all days. And I want to find that choice of W1 to W100, the weights or the importance of each feature, whose combination will best explain the labels, right? So this problem is what we will solve. We won't have time to talk about the techniques to solve this today, but then, there are some standard techniques to solve this, which will automatically, you can write an algorithm that will automatically take this as input and then output W1 to W100. This problem is the problem of linear regression. It is a regression problem, but it's a linear regression problem because, we are combining these in a linear fashion, right? So you might combine the weights, you might combine the apples and oranges however you want, right? So, but then in a price, in the apple orange example, the bill is a linear function of the number of apples and oranges that I have bought. But then in a different problem, it may not be linear, right? So maybe you want to predict rainfall using temperature and precipitation. It's not necessary that there is some 3 times temperature plus 4 times precipitation will always explain the rainfall. Maybe it is 3 times temperature square plus 4 times precipitation cube that will best explain the rainfall. There, you cannot the output is not a linear function of the input. There it won't be still a regression problem. It won't be a linear regression problem. But in the simpler case, the problem is a linear regression problem, which is what we saw today. And we saw how to formulate a linear regression problem. Now, there are some standard solvers. If you take any programming language of your choice, like Python, MATLAB, or whatever it is, there are standard algorithms to solve this, to find these W's. I won't really discuss today in the interest of time these algorithms. Maybe at a different point in this course, somebody will look at these algorithms as well. But there are fascinating algorithms. If you're interested, you should go back and try to understand how exactly can you find this? How can you write a code to find these W1 to W100, right? So automatically using a computer. So we won't get into that. But then what I wanted to do today was give a high level introduction to the problem, one specific problem, and then talk about how you can formulate that. And today it would be the problem of linear regression. So I'll pause here for the day. If there are any questions, I can take them now. Are there any doubts, clarifications? Is this clear what I have written down, or was it too mathematical? I hope not. Feel free to ask any questions. I mean, if you did not follow some part, I can repeat them again if you need me to. Okay, I think there's some interesting questions. Oops. Sorry about that. Go back. Sorry about that. Okay. Yeah. So why did we square? Great question. I mean, that's an amazing question, Rishita. So why did we square and not do absolute value? So basically what Rishita is saying is, why can't we do this, right? So why can't we do this, right? So sum over I equals 1 to whatever 1000, absolute value of W1 F1 plus, let's say, W2 F2, maybe there are only two features, minus YI, right? So why not absolute value? Why did we square it, right? There is so excellent question. There is no reason why squaring. Well, there are reasons, but then there is no reason why you should not use the absolute value, right? So because you finally want to find some deviation, some way to measure deviation from predicted and actual, right? So this is predicted, this is actual. Now, the most natural thing would be to look at the absolute value, right? So how much am I deviating from the actual, right? So it seems like you should be using the absolute value and not the squared value. But then why would somebody want to do squaring instead of absolute value? The reason is purely algorithmic, in the sense that, finally I want to solve this problem. I want an algorithm that will give me the best W1 and W2, best price for apples and oranges. Now it turns out, if you do the squaring, finding this is much easier than doing it if it is an absolute value, right? So because I did not talk about the techniques that you will use to actually solve this problem, it becomes hard for me to convince you why absolute value is why squaring is better than absolute value. But the reason is, the simplest reason, fundamentally, if you dig deeper and deeper, the fundamental reason is the following, right? So square is as the function as, x square is a function like this, right? So this is a function of x, this is x squared. Absolute value is a function like this, right? So it's a sharp function. Now, again, if you've done some basic mathematics courses, right? So you would, you will realize that the square function is what is called as a differentiable function, whereas the absolute value is non-differentiable at x equals 0. Now, why do we care about differentiation all of a sudden? Well, we want to find the minimum over w, some f of w, right? So this f of w, think of this as a loss function. In our case, this loss function can be absolute value or the squared value, right? So when you want to find the minimum of a function, one way to do the minimum of a function is to take the derivative of that function and then try to set it to 0 and see where it becomes 0. Now, if it is a squared function, then taking this derivative and setting it to 0 is easier, right? So you get actually a closed form solution for this W1 to W100. Whereas if it's an absolute value, then you don't get a closed form, right? So we don't know we cannot come up with like a formula for the best W1 to W100. Whereas if it's a squared function, then we can actually come up with a formula. That's the only reason we do squared. It's purely for mathematical convenience. But I mean, if you think absolute value is what you want to do, there are optimization solvers even to solve for absolute value, right? So we can do that also. Yeah. So it's nothing sacrosanct about squared, except that it's easier mathematics. I hope that answers your question, Rishita. It's a great question, though. Yeah. Any other questions? Great. Yeah, I kept the mathematics limited because I wanted to get a high level view. But I mean, for those interested in mathematics, it's pure delight in machine learning. You can dig deeper and you will figure out some beautiful mathematics. Yeah, there are so many courses online. Even there is a course that I did here for the online BS program of IIT Madras. So all the lectures are available on YouTube as well. So in case some of you are interested in digging deeper into this, I would definitely recommend you to watch those as well, right? So if you want to know the precise mathematics of how these algorithms work, and so on. The goal of this school itself is to kind of give you a high level overview. Just to touch upon the most important mathematical aspects. Okay. So if there are no further questions, maybe I'll stop here, and thanks for the opportunity, and hopefully you learned something new today. Thank you.
Thank you, sir. Now I could like to call upon Akshaya to deliver a vote of thanks.
Good evening, all present here. I am Akshaya from Sri Meenakshi Government Arts College for Women. Gratitude is the fairest blossom which springs from the soul. First of all, I would like to thank our principal madam for her outstanding leadership and unwavering commitment to the growth and development of our college. Teachers can change lives, but with just the right mix of chalk and the challenges. I would like to thank our chief guest, Mr. Arut Raj Kumar, sir, Assistant Professor, IITM Chennai. This course was truly worthwhile, sir. You really explained us very clearly about machine learning and linear regression. I hope that we gain more knowledge towards the upcoming schedule. Thank you, sir. Next, I need to thank our faculty members for organizing this amazing course. I would also like to thank the people who work behind the scenes to make this event happen. Thank you, Anandal.
Thank you, Akshaya.
Thank you. Thanks, everyone. And see you hopefully soon.